Okay, welcome to a session where we solve a wave equation for a particular boundary and initial conditions that's specified to us. Okay. First thing is let's discuss a little bit what's going on over here. As you can see in here, I have two boundary conditions. The first one is well x. This is x. Okay. X is equal to 0, and this is where x is equal to L. So they are fixed. And I gave you f of x. Initial shape of the string is like this, and obviously I'm exaggerating this. The displacement cannot be this big, okay, compared to this L is huge. You can see over here the gx is 0. I don't have to give you this, I can use this in words. I can say that the string is released from rest. I'm gonna write the equation, the wave equation, so I'll be right back. Okay, I'm back. So you can see the wave equation over here. I want to highlight one thing right off the bat. Look at the gx is 0, so what happens to this bn term? This drops out, so I don't have to worry about this anymore. So this becomes 0. So then this turns out to be 0 too. Okay, and the an, the way that I'm going to calculate an is I have to look at this f of x, which is supplied to me. This is the graph for it, right? And then I will take the integral and go from there and plug it into here, and pretty much that's it. I first need to actually go back up here and look at these equations, the equation of these three lines. Okay. So the equation of these three lines, you can find if you choose to save time. I'm not going to do one by one, but you can do this ax plus b if you choose to. And let's say that this is, I'm investigating this. You can plug two equations to unknown kind of case, because a and b are the unknowns over here. And what you can do is we can say when x is equal to 0, y is equal to 0. That becomes b turns out to be 0, right? And also I can say that when x is equal to L over 3, I will get myself y is equal to 1. So, your a becomes 3 over L, right? Equations. So this is going to be 3 by L, x. Let's look at this range. You can clearly see this is 1, right? Even I can do it myself. And you need to do this, two boundary conditions. When x is equal to 12 by 3, it's going to be 1. When x is equal to L, it's going to be 0. And what you're going to find is you're going to get this 3 minus 3 by Lx, okay? And we can confirm that. Let's plug x is equal to 12 by 3. What I'm going to get over here is 3 by L's cancel. I get myself 2. So 3 minus 2 is 1. So I'll get this point. And when I put x is equal to L, I'll get, 3 minus 3, 0. So that checks out, okay? So those are the three regions that I have to deal with. Okay, so let's go back and actually start the question. So this an will be 2 by L. And I'll have integral from 0 to, the first step is to L by 3. So that's going to be 3x by L sine, I'm simply copying this, and pi by Lx dx. That's the first one. Actually, let's put a big bracket. So the second range will be from L by 3 to 2L by 3, and that will be, well, 1 times sine and pi by Lx, right, dx. And the third and the last range is going to be from 2L by 3 to L by 3. This will be 3 minus 3x by L, that's what the equation was, times the sine and pi by L times x dx, and close this bracket. So I will do the same thing that I did in the wave equation case. I'll do 1, 2, and 3, then I will add 2 by L times 1 plus 2 plus 3. So let's start one by one. Let's look at the first one. 0 to L by 3, 3x by L sine and pi by Lx dx. So all the integration by parts, and I'm going to call u is equal to x, obviously, du will be dx, and I'm going to call dv will be equal to sine and pi by Lx dx. v will be minus, don't forget that, L by n by pi cosine of n pi by Lx. Right? That's what I'm going to get from this. Let's not forget 3 by L. I didn't really use this. 3 by L in the brackets. I'll get myself minus Lx by n pi cosine of n pi x by L. Let's write this way. It will be easier. Plus, why plus? Because there's negative. L squared by n squared pi squared sine of n pi x by L. Okay? So I have to evaluate this from 0 to L by 3. Minus L by 3, and pi cosine. When I insert x is equal to L by 3, I'm going to get cosine and pi by 3, right? That's what I'm going to get. Sounds not so good. When I insert 0 to here, you're going to see as x is equal to 0, so I don't have to write anything there, so that's vanishes. Plus, I'll have, when I insert x is equal to L by 3, I'll get sine, same thing, m pi by 3, right? What about when insert x is equal to 0? Well, I don't see any x, so this is not going to drop out, but then this is going to be sine 0. What is sine 0? 0. So that drops out. Then let me write this way. Okay, L, and this L cancels, and this L cancels too. L by m pi, so that's common between those two terms. And I first want to write this minus that. It's weird to write minus plus, right? So it's going to be, let's be careful, 3 by m pi, because m pi squared, sine of m pi by 3, and then minus, I have everything, so cosine of m pi by 3. That's it. So let's mark this as 1. Now let's go to 2. Okay, let's write it. So it's going to be from L by 3 to 2L by 3, and I will have basically a sine of m pi L times x dx. So then if I take the integral, I'll get a minus L by m pi, I did in the above step, cosine of m pi x by L, and I have to evaluate this from L by 3 to 2L by 3. Okay, sounds fair. So then minus L by n pi, and then in brackets will be cosine 2n pi by 3, right? Minus cosine of, well, this time out it will be n pi by 3, right? And insert pi over 3. I just want to rewrite this L by n pi, cosine of n pi by 3 minus cosine of 2n pi by 3. Okay, so this is going to be the 2. Let's look at the third one. That will be a little bit more challenging. It's going to be from 2L by 3 to L this time around. 3 minus 3x by L, that was the equation of f of x, sine of m pi by Lx dx. Okay, so I will separate this into two integrals, easy. 2L by 3, L, 3 sine m pi by Lx, right, dx, minus, let's not forget the minus, let's go to the next page, integral 3x by L sine n pi x by L dx. Okay, so when I do it, it's going to be 3L by n pi, it's going to be cosine n pi x by L, and I will have to evaluate this from 2L by 3 to L, minus 3 by L, and this bracket is going to come from up here. I'm going to simply go ahead and plug this. Okay, so I'll take this and I'll copy paste down there, except that I'm going to have, the integral boundaries will be different, okay? Okay, minus Lx by m pi cosine of m pi x by L plus L squared by n squared pi squared sine n pi x by L. Okay, and I have to evaluate this from same 2L by 3 to L. Okay, let's simply insert the first one. So that's going to be minus 3L by n pi. In parentheses, it's going to be cosine of n pi, which is minus 1 to the power of n, right? Minus cosine of 2n pi by 3. Okay, that's fine. Minus 3 by L. So let's evaluate this one. So when I insert L, so that will be a big bracket, minus L squared, right, by m pi, cosine of m pi. And now let me continue by inserting L to the second term too, so it will be a little bit more easier to me at least. It's going to be L squared by n squared pi squared times sine of n pi. Then I will put a negative sign, because now I'm going to put 2L by 3. But then this term, the first term, has a negative in front of it already, so it's going to be L by 2L by 3 by m pi cosine of 2m pi by 3, this time minus, right, L squared by n squared pi squared sine 2n pi by 3. Okay, you really need to tell me that something's cancelled in here, otherwise I will not be very, very happy at all. Okay, I'm losing a parenthesis over here. Okay, let me see 1 second over here. Okay, this is making me happy. I want you to look at this term. and I want you to look at this term. Well, obviously multiply by 3 by L2. Okay, so if I look at it, you're going to see this is going to be, well, minus 3L n pi cosine n pi. This is going to be minus minus becomes plus, plus 3L, right, by n pi cosine. So these are the same. So I can simply go ahead and get rid of these two. Okay, what is sine n pi? We discussed this. This is 0. So that's gone too. So this seems, I mean, you can do some other simplification, but I don't want to go too far ahead. So let's write one more time then. Okay, so this is going to be 3L, now positive, by n pi cosine of 2n pi by 3. That is given. The first term dropped out. That term dropped out. So I have two more terms. Minus, this is going to else will cancel there. So I'll get 2L, 3 is cancel 2, by n pi cosine of 2n pi by 3 plus, let's look at the last term, that will be L square. L, one of the L's will cancel, so it's going to be 3L by n square pi square sine 2n pi by 3. So you can see the first two terms, one is 3, the other one is 2, so it's going to be, you know, subtracting from one another. When all said and done, I will get myself L by n pi cosine of 2n pi by 3 plus 3L by n squared pi squared times sine of 2n pi by 3. That's it. So let's go back and write this. This is 3. So, you know, just to remind ourselves, this an was 2 by L, 1 plus 2 plus 3. So that's exactly what I'm going to do over here. Okay. Let's start. An will be equal to 2 by L. Let's look at the first one. So the first one right here. Okay, so I'm gonna actually copy paste this. Sorry for being lazy, but I wanted to copy paste this because it's a long, you know, segment. Okay, so that's the first term that I have. The second one will be, well, it's right here, and I'll copy paste that too. Okay, where is it? Right here. So let me go back and I'll be back. Let me copy paste this. Okay, I'm back. You can see what happened over here. This is 1. This is 1. This is 2. And let me go and let's not forget the plus sign. And the third one is actually right over here. So I will copy paste this. I'll be right back as well. Okay, I copy pasted that and then close this whole bracket. So everything is multiplied by 2 by L. So let's take a look at what is canceling. I should see some cancellations over here. Let's turn on my red marker. So you can see I mentioned actually, look, right? Both of them are multiplied by L by n pi. One has a negative, one has a positive. Okay, let's look from here to here. You see what is going on over here? Expectedly, because the integrations are limits are the same, so I will be able to get rid of these two too. Okay, so that's gone. So I'm on the left with the first and the last term. So then if I rewrite this, actually let's not move because I want to see everything. An will be equal to, now don't forget the 2 by L. So that's going to be, the first term will be 6, L's cancel, by n squared pi squared times sine n pi by 3. So that's the first term. Okay. How about the second term, or rather the last term that I'm looking here? See, this is the thing. This has the same, so I'm gonna do this, right? 6 divided by n squared pi squared plus sine of 2n pi by 3, 2. So that's it. This is my an, the whole thing, when all said and done. But I want to just investigate this an for a minute here because you'll see why in a moment. Okay, so let me do a1 just to give you a flavor. So it's going to be 6 by n is 1, so it's going to be 6 by pi squared, and it's going to be sine 60 plus sine, I'm writing in degrees, 120, right? Because when n is equal to 1, it's pi over 3 over here, and this is going to be 2 pi over 3, which is 120. Perhaps you do know this as well, but this is going to be square root of by 2, this is going to be square root of by 2, so if I, well, basically sum them up, I'll get myself 6 square root of 3 by pi squared. So that would be my a1. Let's look at a2. So it's going to be 6 pi, and it's 2, so it's going to be 2 square pi square, and then this is going to be sine of 120 plus sine of 240. Now you will get to see why I'm doing this. So this will be square root of 3 by 2, it's up there. This is going to be Actually, this is minus square root of 2 by 2 because it's in third quadrant. Remember, sign is negative in the third quadrant. So you can see this becomes 0. Let's do A3. A3 will be 6 by 3 square pi square, and it's 3. And then I will have sine of 180 plus sine of 360. Do you see what's going on over here? Sine of 80, sine pi, 0. Sine 2 pi, 0. So what did I get over here? I got the third one, it is 0, 2. So let's look at the fourth one. 6 by 4 square pi square sine 240, which is a negative square root of 3 by 2, plus sine 480. Now I'm going back, so basically this is the same as sine of 120, right? So this is minus square root of 3 by 2, and sine 120 was square root of 3 by 2. Okay, now you get to see why I'm doing this, right? The fourth one becomes 0, 2. So let's look at the fifth one. So it's going to be 6 by 5 square pi squared, okay? And this is going to be sine of 300 plus sine of 600. This is the fourth quadrant, right? 300. So do you remember that this is going to be negative 2? And sine of 600 is sine of 240, right? So it's going to be minus square root of 2 square root of 3 by 2, 2. There we go. So this will be minus 6 square root of 3 by 5 square pi square. Okay, let's look at A6. I'll finish up A7. Okay, just one highlight. 6 by 6 square pi square. It's going to be sine 360 plus sine 720. This will be 0, 2, right? Because this is 0, this is 0. And last but not least, now I'm going to actually start to reset the whole series. I'll have sine of 420. What is 420? 60 plus sine of 840. Okay, square root of 3 by 2, square root of 3 by 2. So I'll get myself 6 square root of 3 by 7 square pi square. Okay, I'm gonna stop here but with my analysis. But here's what I want to tell you. You can see the first one stays, right? Second one goes away. Every third time, 3, 6, 9, 12, etc., all the way to infinity will be 0. Why? Because you always will hit the 180 and 360 multiples of it. Okay, so those will be gone. How about the even ones? You can see 2 is 0, 4 is 0, 6 is 0. So I only left with odd ones, except when it's a multiple of 3. So you can see I have a kind of like a pattern over here. So that's why I wanted to write my entire u as this way. So let's write u will be equal to n is equal to 1 to the infinity, okay, an cosine of m pi a by l times t, and sine, remember bn is 0, n pi by l x, okay? And I have an over there, so I want to write this way. So, okay, so 6 by square root of 3 by pi square. Also, one thing I forgot to mention is you can see if it is 7, this is 7 square. If it is 5th, this is 5th square. And if this is 1, it's 1 square, right? Just to highlight. So then I will have cosine of n is 1. So it's going to be cosine of pi a t by l, right? Times sine pi x by l. That's the first, right? Now minus, and this will be minus plus minus plus minus plus 1 by 5 squared. This is the fifth one. It's going to be cosine of 5 pi a t by l times, that's right here, sine 5 pi x by l. Okay, and then plus, I'll have 1 by 7 squared cosine of 7 pi a t by l times sine 7 pi x by l, and the next one will be negative because we go, positive, negative, positive, negative. What will be the next one? I don't want to do it, but I'm going to stop here. But what's the next one? Is it going to be 9? No, 9 is multiple of 3. Is it going to be 11? Yep, you got it. It's going to be 11th one, okay? But I'm going to stop over here so it goes to infinity over here, okay? So this is the displacement for this particular case, for up to infinity, this is what's going to happen. All right. So thank you for watching this segment. It's been a long segment, so I'm done with the wave equation. I'll come back with the Laplace equation. Have a good day.